Hello everyone and welcome back. In the last video we ended talking about trig ratios. We talked about SOHCAHTOA and how that means sine is opposite and hypotenuse, cosine is the adjacent and the hypotenuse, tangent is opposite and the adjacent. And today we're going to talk about how these ratios actually help us to find angle measures. So we can't just leave it as theta and say sine of theta is 4/5 because who really cares? We can see that because we know what the side measures are. But now we're going to see how this helps us to find out what theta actually is. So we are able to write usually sine of theta equals 4/5. That's a nice ratio. So let's see if we can figure out the same kind of ratio with this triangle here. This is what's called a 5, 12, 13 triangle. And if you can tell, it's because the sides are 5, 12, 13. This is a special triangle. And it's because it's a right triangle with those sides always will make perfect side lengths. Like each of these are whole numbers is what I'm trying to say. So now, as you can see up here, we're going to be using inverse trig functions. Now, before we even get into that, think about what you know an inverse function is. So if we would have something like 3x equals 18, we want to know what x is, we have to undo this 3 times x that's going on. So to undo multiplication, we do the inverse operation, which is division. So if what we do to one side, we have to do the other. We divide by 3 on one side. That leaves us with x equals 18 divided by 3, which is 6. We could do the same thing with addition and subtraction being inverse operations of each other. We also talked about how if x squared equals 25, to undo the squared, we have to do the inverse operation of squaring, which is square rooting. And those cancel out the squared that's going on. And what we do to one side, we do to the other. Therefore, x would equal 5. So each of these things are talking about inverse operations. It's the same idea with trig functions. So when we have, go back here for a second, if we have sine, cosine, and tangent, each of these will have an inverse operation. So the inverse of sine is what's called inverse sine. Inverse of cosine is what's called inverse cosine. Inverse of tangent, great. You figured it out, inverse tangent. Awesome. So we're still talking about SOHCAHTOA, and I'm going to write that down here again, just so we keep it in mind. And I'm going to go a little overkill in this problem just so you can see all the ways it works, and then we'll show an example with less overkill. So if we're looking for the measure of angle theta, that's this guy down here, we could do it 3 different ways. We could either use sine, cosine, or tangent. So let's start with sine. And if I'm looking at theta, I'm going to label my sides first. We have our opposite, we have our adjacent leg, and we have the hypotenuse. Now, using that, if we want to use sine, we would have sine of theta in our ratios we know is opposite over hypotenuse, opposite being 5, hypotenuse being 13. So that's all fine and dandy. We know it's 5/13. That's our ratio. But that doesn't tell us anything about the angle. So basically what we're trying to figure out is what is theta. So we want to get theta by itself. So the way we would do that is we could take the inverse of sine, which you write it as sine of -1 of sine theta. And what we do to one side, we have to do to the other. So what we're saying here is this sine of -1 cancels out that sine, and we're left with theta. And so theta equals the inverse sine of that ratio we came up with, 5/13. Now, if we type this into our calculator, it's really important. Every time we're using our calculator, it's in degree mode. Now, if you don't know how to put it into degree mode, I would check this first. Go in your TI-83, TI-84, turn it on, click the mode button. It's like the second one down on the left. And when you click that, you want to look at the second row, and it's going to say rad and deg, R-A-D or D-E-G, or maybe it'll say radians and degrees. Make sure you have degree mode on. That is very, very important, or you'll get some weird decimals. All right, so then you'd want to type this into your calculator. You would hit the second button. It's like this. Says second, the colorful one, you click it and then hit the sine button. That gives you your sine -1. Then you would type in 5/13. When you type that in your calculator, it should come out with something like 22.6 degrees. And that is what theta equals, 22.6. Now, if we want to do this another way, I said we could do it 3 different ways. We could also talk about cosine of theta, because we aren't always given the opposite. Sometimes we're given the adjacent. So in this case, if we were looking at the cosine of theta, we would want the adjacent, cosine is adjacent over hypotenuse, I'd want my 12/13, and that's our ratio. So now if we're trying to get theta by itself, we have to undo this cosine that's already done. We want to do the inverse operation, which, as we've talked about, means we're doing cosine of -1, our inverse cosine. What we do to one side, we have to do to the other, so those cancel out. Theta is left with cosine of -1 of 12/13. And when you type that in your calculator, you still get 22.6 degrees, which is good. We don't want theta, this angle right here that doesn't change no matter if we're using sine, cosine, or tangent, to be anything other than 22.6 at this point. And lastly, we could use tangent of theta. We know tangent is opposite over adjacent. Oop, look down here. Opposite over adjacent. So if I look here, I have my opposite of 5, my adjacent of 12. So I have 5/12. Then, if I want to undo it, I use my tangent inverse to cancel that out. And what I do to one side, I do to the other. I'm left with theta equals tangent inverse of 5/12. And when you type that in your calculator, you still get 22.6 degrees. So whether you use sine, cosine, or tangent, you can really pick your favorite. You're always going to get the same answer for what is theta. You're going to get that 22.6 degrees in this case, for this triangle. Now, if we're looking for the measure of angle alpha, then this is this other angle. There are a couple ways we could do this now. We already know, let's put this here, theta equals 22.6 degrees. Now, this is still a triangle, so all triangles have to add up to 180 degrees. So if we know this angle right here is 90 degrees, this angle is 22.6 degrees, I could do, let's use this color, 180 degrees minus 90 minus 22.6, and we're left with 67.4 degrees. That's what alpha is going to equal. So when we do this, we're still going to check our sine, cosine, tangent functions because that's what we're working with today, but we should always get 67.4 degrees. Otherwise, we don't have a real triangle, and then this would all be pointless. So let's look in this case. Now we're looking at alpha. I'm going to label my triangle. We have our opposite, our adjacent, and the hypotenuse always stays the same. So if I'm looking for the sine of alpha, this is going to be our opposite over hypotenuse. Opposite in this case is 12, hypotenuse is 13. So I have sine of 12/13. We want to undo this sine. We use our inverse sine function. That cancels that out, and what we do to one side, we have to do the other. So we know alpha equals the inverse sine of 12/13. And if you type that in your calculator, you still get that 67.4, which is what we were looking for. Same idea if we use cosine of alpha. Cosine is adjacent over hypotenuse. So we look at our adjacent is here, purple, 5/13. We want to undo that. We use our cosine inverse. Cancel that out. What we do to one side, we do to the other. So we're left with alpha equals the cosine inverse of 5/13. And when you type that in your calculator, we still get 67.4 degrees. Last but not least, again, this is why it's overkill. We're doing it 3 different ways when you only really have to do it one way. So if we're looking for the tangent of alpha, I look and tangent is opposite and adjacent. Opposite is 12, adjacent is 5. I want to undo my tangent, so we do tangent inverse. And what we do to one side, we do to the other. At this point, you should know when we do one thing to one side, we have to do the same thing on the other side. Keep those equations balanced. So if we do the inverse tangent of 12/5, we again come up with 67.4 degrees. Awesome. So this ends up being a wonderful triangle. We could have used either just sine, just cosine, just tangent. We did it a lot of different ways. So let's look at one where we don't have a million different options. So if we have something like this, we're still going to use our inverse trig functions. Whenever we're using inverse trig functions, that's helping us find angle measures. That could be helpful for you to write down. Inverse trig functions help us find angle measures. That's very important. So if we're looking at example 2 here, we have another triangle. In this case, we only have 2 of the sides. And I'm going to write SOHCAHTOA down here again. So I have that as a reference. Always helpful to have. And we're looking for the measure of angle D and the measure of angle E. So in this case, angle D is this guy right here, angle E is this guy right here, and I'm going to just mark the first one. I'm going to call it theta. It's just helpful for me to know what angle I'm talking about. So if I'm looking at that first angle, I'm going to label my sides. My opposite, my adjacent's the leg next to it, and the hypotenuse will always be that 29 there across from the right angle. So if I'm looking at this, I don't know my opposite, but I know my adjacent and my hypotenuse. So if I look down here for SOHCAHTOA, the one that uses adjacent and hypotenuse is going to be cosine. So instead of trying the 3 different ones, I'm just going to start right off the bat and say the cosine of theta is my adjacent over hypotenuse, so 20 over 29. Now, that didn't give me the angle measure yet. To get the angle measure, I have to get theta by itself. So to get rid of this cosine, I use my inverse cosine function. That cancels that out. And what I do to one side, I do to the other. So cosine of -1, so the inverse cosine of 20 over 29. I'm going to type that in my calculator, and I end up with 46.4 degrees. So that's what we get for theta up here, 46.4 degrees. Now, if we wanted to, for the measure of angle E, I could just do 180 minus the 90-degree angle minus our theta, so minus 46.4, and I end up with 43.6 degrees. But let's do it with using some trig functions just to keep practicing that. So for measure angle E, I'm going to call it alpha. I like using the Greek letters for these because that's what a lot of mathematicians would do. And I'm looking at my relationships. I have an opposite, I have my adjacent, and I have my hypotenuse again. So if you see, this time we're missing an adjacent, and we only have the opposite and the hypotenuse in relation to that angle alpha. So if we look down here at our functions, sine is the one that uses opposite and hypotenuse. So I would use sine of alpha is our opposite, 20, over the hypotenuse, 29. Opposite, hypotenuse. Now, just like we did on the last problem, we want to use our inverse sine function to get rid of sine to leave alpha by itself. What we do to one side, we have to do to the other. So alpha is equal to the inverse sine of 20 over 29. And then if you type that in your calculator, we're going to end up with that same 43.6. Again, I'm rounding some of these to the nearest tenth. So we end up with 43.6, which is perfect to make a triangle of 180 degrees. So you're going to be practicing this week with trig ratios and inverse trig functions to find angle measures. And then next week we are going to continue more with how the sides relate to everything else. So good luck. Let me know if you have any questions.